Now we move from concepts to architecture. In this module, you'll see how agentic security systems connect with SIEM, SOAR, EDR, identity, cloud, and ticketing tools through practical, governed, enterprise-ready reference patterns. With the foundation in place, what agentic AI is, how it differs from automation, and why tools, policies, and guardrails matter, we can focus on placement, where agents connect inside real security operations. Reference architecture turns agentic defense from a clever prototype into an operational capability. It gives security, cloud, incident response, and governance teams a shared blueprint. That blueprint defines where agents get data, which tools they can use, when approvals are required, and where humans stay in control. Without it, teams risk isolated agents, unsafe automation, and fragile integrations that fail under real SOC pressure. Think of the agentic layer as a controlled decision layer, not a replacement for your security stack. SIEM, ADR, identity, firewalls, and ticketing systems remain the systems of record and enforcement. Agents sit above them, pulling context, reasoning over tasks, and using approved connectors to act. Policy engines, memory, audit logs, and human approvals constrain those actions. The goal is faster coordination with clear accountability, observable decisions, least privileged tool use, rollback paths, and review for high-risk cases. In practice, agentic security works as a coordination layer across the tools teams already use. SIEM provides alerts, logs, correlation, and timelines. SOAR manages cases, approvals, playbooks, and response steps. EDR and XDR contribute endpoint telemetry and enable containment or malware investigation. Cloud and IAM platforms add identity, entitlement, asset, and exposure context. The agent connects these surfaces so alerts can be enriched, investigations guided, and approved actions executed consistently. Agents can enter the security workflow at several points. They begin by consuming signals, alerts, logs, assets, identities, and threat intelligence. From there, they enrich those signals by querying systems such as SIEM, EDR, cloud APIs, CMDBs, and scanners. Then they summarize evidence and recommend investigative steps. Actions come last, such as containment or ticket updates. The key design choice is autonomy. What happens automatically? What requires supervision? And what stays strictly human-led? A useful design principle is to separate what the agent can know from what it can do. The data plane is evidence: logs, alerts, identity signals, cloud state, and vulnerabilities. The control plane is authority: actions, playbooks, approvals, escalation, and rollback. Agents may reason across both, but access should be gated. This separation limits blast radius, improves auditability, and makes failures easier to contain. The data plane defines what the agent is allowed to know and how trustworthy that knowledge is. Start with high-value telemetry: SIEM alerts, EDR, IAM, cloud logs, asset inventory, and vulnerabilities. Normalize around shared identifiers such as user, host, IP, asset, account, and workload. The goal is not to pour raw logs into prompts. It is to retrieve focused evidence with access controls, retention limits, classification, and privacy safeguards built in. The control plane is the agent's safety boundary. Begin by classifying actions by risk: reading data, making low-risk changes, taking reversible actions, or causing business impact. Then let policy evaluate role, context, confidence, and severity before anything executes. High-impact actions need human approval and clear escalation, especially for isolation, account locks, firewall changes, or mass remediation. Finally, log the reasoning, tool calls, approvals, and outcomes immutably, so every decision remains accountable. In a centralized model, one orchestrator becomes the control plane for security work. It receives alerts, pulls context, decides the next step, calls tools, and tracks workflow state. Governance is simpler because policy checks, approvals, audit logs, and monitoring all pass through one place. This pattern is especially useful for triage, enrichment, ticket summaries, and guided investigations. The trade-off is concentration of risk. So design for scale, failover, and clear human approval points. A swarm model takes a different approach. Each agent has a narrow security specialty, such as endpoint evidence, identity risk, cloud posture, malware analysis, or case handling. That specialization lets agents use the right tools, prompts, permissions, and evidence models without one overpowered assistant touching everything. The trade-off is coordination. Agents need shared case context, task routing, consensus when findings conflict, and escalation paths when confidence is low. Done well, the swarm scales investigations while limiting blast radius. Centralized orchestration gives you control. Governance, testing, monitoring, and explanations are simpler because decisions flow through one place. The trade-off is scale and flexibility. A specialized swarm can handle many domains in parallel and isolate failures when each agent has bounded permissions. But coordination, consistency, and debugging become harder. Most enterprises start centralized, then move toward a hybrid pattern as trust, observability, and governance mature. Agentic security does not have to live in one place. Cloud components work well for scalable reasoning, centralized analytics, and SaaS visibility. On-prem agents protect sensitive logs, regulated systems, and internal networks where local control matters. Edge agents support fast detection and response near branches, factories, devices, or operational technology. In hybrid designs, data can be processed locally, while policies, audit trails, and orchestration remain centralized, giving teams both speed and governance. Reference architectures become most useful when they map to real security jobs. A triage assistant turns SIEM alerts into enriched severity judgments and analyst recommendations. An incident response agent moves from EDR evidence toward containment, approval, and SOAR execution. Cloud posture agents prioritize CSPM findings and route remediation to owners. Identity agents analyze IAM behavior, trigger reviews, and apply conditional controls. The architecture pattern is shared, but the data, tools, approvals, and deployment model change. Reference architectures turn agentic AI into governed security operations. Keep agents integrated with SIEM, SOAR, EDR, IAM, ticketing, and cloud tools. Separate data from control for safety and auditability. Then choose the right orchestration pattern: centralized, swarm, or hybrid. Next, we move from blueprints to coordinated agent behavior and design patterns.